Ever heard of a math problem about the solar system that
Uh,
kicked off a century-long quest to figure out the shape of the universe?
hmm.
Sounds kind of wild, right?
Yeah.
Well, that's just a taste of what we're diving into today, the mind-blowing life and work of Henri Poincaré.
Okay.
We've got excerpts from a book all about him, a mix of biographical stuff and some pretty complex math and physics.
Right.
Don't worry, we'll make it clear, insightful, and maybe even a little relevant to your everyday life.
What's so captivating about Poincaré is that he wasn't just a mathematical genius.
Right.
He excelled in physics and philosophy, too,
Wow.
making groundbreaking contributions across these fields.
Hmm.
This deep dive is really a journey into understanding the fundamental nature of space-time and how we perceive the world around us.
So let's start with the basics. I mean, this guy was obviously brilliant,
Right.
but what was his childhood like? Was he some kind of prodigy from day one?
Well, his early life was a fascinating mix of intellectual promise and serious challenges.
Okay.
At 5 years old, he got hit with diphtheria,
Oh, wow.
a really nasty illness that left him unable to walk or talk for months.
Oh, gosh.
It's hard to believe he fully recovered and went on to achieve such amazing things.
Wow, talk about resilience. It makes you wonder if overcoming that kind of adversity early on played a role in shaping his determination later in life.
Yeah.
What about his family? Any other notable figures in the mix?
His family background is particularly interesting because it blends intellect and politics.
Okay.
Poincaré's cousin was Raymond Poincaré, the French president during World War I.
Whoa, imagine those family dinners. But let's dive back into the world of math.
Mm.
What was the scene like when Poincaré was starting out?
It was a time of intense debate in the mathematical world.
Okay.
Some believe math should be all about rigorous, airtight proofs,
Yeah.
while others felt there was room for intuition and those aha moments of insight.
Ah, the classic battle between logic and gut feeling.
Exactly.
It's a tension that exists in so many fields even today.
Yeah.
So where did Poincaré stand on this?
Poincaré saw the value in both approaches.
Hmm.
He believed in the power of rigorous proof, but also recognized the crucial role of intuition.
Yeah.
What set him apart was his incredible spatial reasoning abilities.
Right.
He could visualize complex mathematical structures in his mind.
Wow.
And this talent fueled many of his discoveries,
Oh.
especially in topology.
Okay. Topology.
Yeah.
For those of us who barely survived high school geometry,
Right.
what exactly are we talking about here? It's not just about triangles and circles.
It's geometry, but on a whole other level.
Okay.
Topology is about the fundamental properties of shapes.
Hmm.
Things that stay the same, even if you stretch, twist, or bend them.
Okay.
Think of it this way. A coffee mug and a donut actually share the same topological properties.
Really?
They both have one hole.
Wait, a coffee mug and a donut are basically the same thing.
In topology.
That's a mind-blowing way to look at breakfast. But before we go down that rabbit hole,
Sure.
let's rewind to Poincaré's early work.
Right.
What kind of problems was he tackling back then?
His initial focus was on differential equations.
Okay.
These are crucial in physics and engineering for understanding how things change over time.
Right.
To solve them, he invented something called automorphic functions.
Automorphic function.
They were initially called fusion functions after another mathematician.
Ah, the world of academia.
Right.
Full of fascinating discoveries and I bet a bit of rivalry, too.
You're right about that. There's a great story about Poincaré's rivalry with the German mathematician Felix Klein.
Okay.
It highlights the competitive yet collaborative spirit of the time. You see, Poincaré realized Klein had actually come up with the initial idea for a specific class of transformations. So he named them Kleinian in a display of academic integrity.
Wow. So even amidst the competition, there was a sense of respect and recognition for each other's contributions. That's pretty cool. But let's get back to these automorphic functions.
Sure.
How did they lead Poincaré to his breakthroughs in topology?
This is where his exceptional spatial reasoning really shines. While working with these functions, he discovered a way to tile a disk with non-repeating shapes that only become congruent in hyperbolic geometry,
Okay.
also known as non-Euclidean geometry.
Hold on. Non-Euclidean geometry.
Yeah.
Isn't that where parallel lines can actually meet? My brain is starting to hurt.
It's a totally different way of looking at space,
Okay.
and it's key to understanding Poincaré's impact.
Okay.
What's so fascinating is how this complex math can inspire stunning visuals. Think about the artwork of M.C. Escher.
Right.
His mind-bending patterns often draw inspiration from non-Euclidean geometry.
Okay, we've got a brilliant mind, a dash of academic rivalry, and a connection to the mind-blowing art of Escher. What's next in Poincaré's adventure?
Well, imagine a prestigious math contest hosted by King Oscar II of Sweden.
Wow.
Poincaré decided to tackle the infamous three-body problem,
Okay.
a problem that had stumped astronomers and mathematicians for centuries.
The three-body problem. That sounds like something out of a science fiction novel. What is it exactly?
Picture trying to predict the movements of three celestial bodies,
Okay.
like the sun, earth, and moon,
Right.
all pulling on each other with their gravitational forces.
Yeah.
It's incredibly complex.
Yeah, I can see how that would be a major challenge. So how did Poincaré approach it?
He showed he could find approximate solutions.
Hmm.
But here's the twist. His solution also proved that the three-body problem, as originally stated, was actually unsolvable.
Wait, he won a contest by proving the problem couldn't be solved? That's kind of amazing.
Yeah.
It's like saying, I've figured out that you can't figure this out.
Exactly. It demonstrates the power of deep mathematical thinking.
Right?
Sometimes the most profound insights come from understanding the limits of what we can know.
Yeah.
And this is just the beginning of Poincaré's mind-blowing contributions to our understanding of the universe.
Okay. Okay. I'm definitely getting the sense that Poincaré wasn't afraid to tackle the really big, mind-bending questions.
Oh, yeah.
But I'm also curious about how his ideas connected to the real world. Was he just a solitary genius working away in his ivory tower? Or did he engage with the events of his time?
It's easy to imagine these figures working in isolation.
Hmm.
But Poincaré was very much a part of his time.
Okay.
He was deeply engaged with social and political issues.
Hmm.
And one of the most dramatic examples of this is his involvement in the Dreyfus Affair.
Wait, the Dreyfus Affair?
Yeah.
That was a huge political scandal in France, a case of wrongful conviction fueled by anti-Semitism.
Right.
What did a mathematician have to do with all of that?
Poincaré's involvement really shows his commitment to truth and justice beyond his theoretical work.
Okay.
Alfred Dreyfus, a Jewish artillery officer, was falsely accused of treason based on incredibly weak evidence, including some flawed statistical analysis.
Okay, I'm starting to see where this is going. So they brought in Poincaré, the math whiz, to sort things out.
Exactly. Poincaré, with his expertise in probability and statistics, was asked to examine the analysis used against Dreyfus. He saw right through the errors and showed how the statistics had been manipulated,
Wow.
which played a key role in exposing the injustice of the whole case.
That's amazing. He used his mathematical skills to fight for what was right.
Yeah?
It adds a whole new dimension to his legacy, doesn't it? It shows he wasn't just about abstract ideas.
Right.
He was willing to stand up for what he believed in.
Absolutely.
Yeah.
And it highlights how someone deeply immersed in abstract thinking
Right.
can also be deeply concerned with real-world issues.
Yeah.
This commitment to truth and justice is also reflected in Poincaré's philosophical work.
Okay.
He wrestled with questions about the nature of knowledge, the limits of what we can know, and the role of human perception in shaping our understanding of the universe.
Okay, let's talk about Poincaré the philosopher.
Yeah.
What were some of the big ideas he grappled with?
His philosophical stance, known as conventionalism, is really thought-provoking,
Okay.
though maybe a bit mind-bending.
Okay.
He argued that in science, we don't necessarily discover absolute undeniable truths, but rather we choose the most convenient rules and frameworks to help us describe and understand the world around us.
So instead of searching for the truth, the capital T,
Right.
we're choosing the most useful explanations. That's a pretty radical idea, especially for a scientist.
It is. And Poincaré used real-world examples to illustrate his point.
Okay.
For instance, he analyzed how we measure the speed of light.
Okay.
He argued that the way we define and measure it involves certain conventions,
Right.
choices we make about how to set up experiments and interpret the results.
So even something as fundamental as the speed of light isn't completely objective.
Right.
It depends on how we choose to measure it. That's making me question everything I thought I knew about physics.
Exactly. Poincaré was challenging the idea that science is purely about uncovering fixed, absolute truths.
Right.
He saw a role for human choices and conventions in shaping our understanding of the universe.
You know, I'm starting to see how his philosophical ideas connect with his mathematical work on non-Euclidean geometry.
Yeah.
It's all about challenging assumptions about what's fixed and absolute, isn't it? He seems to be saying that maybe our perspective plays a bigger role in how we understand the world than we realize.
That's a brilliant connection. Poincaré's thinking was incredibly interconnected.
Yeah.
He saw links between seemingly disparate fields, and his work constantly questioned the boundaries we often place on knowledge.
Yeah.
He even extended these ideas to the realm of physics, making significant contributions not only to relativity,
Right.
but also to the then emerging field of quantum mechanics.
Quantum mechanics. Now we're talking about the world of atoms and subatomic particles where things behave in ways that seem to defy logic. What did Poincaré contribute to that field?
His work on quantum mechanics came at a crucial moment.
Okay.
Physicists were struggling with Max Planck's revolutionary quantum hypothesis.
Okay.
The idea that energy exists in discrete packets or quantum.
So instead of energy flowing smoothly like a wave, it's more like a series of tiny bursts or packets. It's hard to imagine energy behaving that way.
It is a radical departure from classical physics, for sure.
Yeah.
And Poincaré, with his signature rigor, proved that Planck's hypothesis wasn't just a convenient mathematical trick. It was actually necessary to explain certain phenomena.
Right.
Particularly the behavior of light.
Wow. So he helped to solidify one of the foundational principles of quantum mechanics. It's incredible to think how his work touched on so many different areas of science.
Yeah.
He wasn't just a mathematician or a physicist.
Yeah.
He was a true intellectual giant whose ideas continue to shape our understanding of the universe.
He was a pioneer in so many ways,
Okay.
pushing the boundaries of what we thought was possible.
Yeah.
And, we're still grappling with the implications of his work today, especially his ideas about the nature of truth and the role of human perception in shaping scientific knowledge.
That's a perfect segue into the final part of our deep dive. We've explored so much about Poincaré's life and work.
Right.
But what does it all mean for us today? What are the big takeaways, the enduring lessons we can learn from this extraordinary individual? So we've covered a lot of ground, from the shape of the universe to the Dreyfus affair, even touching on Poincaré's fascinating philosophy.
Right.
But what's the takeaway for someone who isn't a mathematician or physicist? How do these big abstract ideas actually connect to everyday life?
That's the beauty of Poincaré's work. It wasn't just about equations. It was about grappling with fundamental questions about the nature of reality and the role of human choice in shaping our understanding of the world.
I can see how that resonates beyond academia, but can you give a specific example of something Poincaré believed that might actually change how we think about the world?
His idea that mathematical axioms are chosen, not inherently true, is a pretty mind-blowing concept. It challenges the notion that math is the realm of absolute certainty.
Okay.
Instead, he's suggesting there's an element of human choice involved.
Right. Even in math.
Wait, so the basic building blocks of math aren't set in stone?
It's not that simple, but
Okay.
yeah, in a way.
They're more like tools we choose to use based on what's useful or convenient? That's a wild thought.
Exactly. Poincaré believed we create mathematical systems to fit our needs and purposes. It's like choosing the best language to describe a particular phenomenon.
Okay.
One language might be more elegant or efficient than another,
Right.
but that doesn't mean it's the only way to describe the world.
Okay. I'm starting to see math in a new light, more like a set of tools or languages we use to make sense of things.
Yeah.
But how does that apply to everyday life? I mean, I'm not exactly proving theorems when I'm deciding what to have for dinner.
Think about the choices you make every day.
Okay.
You're constantly weighing options, considering pros and cons, and ultimately making decisions based on your values and goals.
Right.
You're essentially creating your own axioms,
Okay.
the principles that guide your choices, and then building your decisions from there. So even in simple everyday decisions, I'm engaging in a kind of personal axiomatic system.
Exactly.
I like that. It makes me feel a bit more like a mathematician, even if I'm just choosing between pizza and tacos.
Exactly. It highlights the idea that even in ordinary activities, we're constantly interpreting, choosing, and making meaning.
Right.
We're not just passively observing the world.
Right.
We're actively shaping our experience of it.
That's a powerful thought. And it brings us back to one of Poincaré's core ideas, conventionalism.
Right.
He was arguing that even in science, our choices and perspectives influence how we understand the world.
Precisely. He believed that while the universe may have certain inherent properties, the way we perceive and describe those properties is influenced by the conventions and frameworks we choose to use.
Right.
It's a reminder that our understanding of the world is always evolving, and that there's always more to discover and explore.
This deep dive into Poincaré's world has been truly illuminating. We've journeyed from the vastness of the cosmos to the intricacies of mathematical systems, all while uncovering profound insights about the nature of knowledge, truth, and the power of human choice.
I agree. Poincaré's legacy is a testament to the power of a curious and relentless mind. His work wasn't just about advancing specific fields, it was about expanding the horizons of human understanding.
And that brings us to our final thought for today. If even mathematical axioms are chosen not inherently true, how does that change how you think about truth in science and everyday life, or even in your own personal beliefs? It's a question worth pondering.
It certainly is. And for those who want to delve deeper into these ideas, I highly recommend exploring Poincaré's philosophical writings. They're surprisingly accessible and incredibly thought-provoking, even for those of us who aren't mathematicians or physicists.
Great suggestion. It's a reminder that Poincaré's work continues to resonate today. So keep asking those big questions, keep exploring, and never stop challenging the boundaries of what you think you know.
Beautifully said.
And on that note, we'll wrap up this deep dive into the life and work of Henri Poincaré. Thanks for joining us. I happen